everyone, my name is Jin Hongdeng. I'm a second-year PhD student at UESDC. This paper addresses cross-domain object detection. We start from analyzing the challenges of self-training in cross-domain object detection. First of all, the existing works adopt the classification score to select shoulder labels, which neglects the inconsistency between the classification and localization. Second, previous works usually leverage a hard threshold for selecting confidence shoulder-labeled instances. Unfortunately, it will ignore the valuable hard examples to the model training. Therefore, we propose Harmonious Teacher, which includes Harmonious Model Learning and Harmonious Example. Harmonious Model Learning recognizes the consistency of the classification and localization scores when training the detection model. The Harmonious Example Reweighting takes all shoulder-labeled examples from teacher network to guide the student model. Above, I have given a brief summary of our work. In the following, I will introduce our work in detail. As we all learn, object detection is one of the fundamental tasks in computer vision. It aims to recognize and localize objects in images. It can be used in various applications such as autonomous driving, image retrieval, video understanding, and so on. When we deploy a detector in a lower domain, the model will suffer from significant performance degradation due to domain gap. In this work, we address the problem of cross-domain object detection, where we transfer the knowledge from the labeled source domain to the unlabeled target domain. Existing works can be roughly divided into two categories. The first is domain alignment, that tries to minimize the domain gap between the source and the target domains. The second is the self-training methods, which generate the shoulder labels for the unlabeled target images. The self-training methods have achieved promising results because self-training could maximally leverage the target information. It usually includes 4 steps of shoulder labeling in object detection, including obtain the predictions of teacher network, apply NMS, score-based thresholding, and label assignment. In this work, we propose a harmonious teacher which addresses the challenge of self-training in CDOD. First of all, the existing works adopt the classification score to select shoulder labels, which neglect the inconsistency between the classification and localization. For example, we could see many inconsistency predictions in the target domain. The existing works may select the high classification score but low localization quality shoulder labels. Second, previous work usually leverage a hard threshold for selecting confident shoulder-labeled instances. Unfortunately, it will ignore the valuable hard examples to the model training. Therefore, we propose Harmonious Teacher, which include Harmonious Model Learning and Harmonious Example Reweighting. Harmonious Model Learning recognizes the consistency of the classification prediction and the localization score when training the detection model. The Harmonious Example Reweighting takes all shoulder-labeled examples from teacher network to guide the student model, so that the hard threshold is not needed anymore. To improve the consistency of the classification and localization score, we utilize a variable loss to recognize the consistency between the classification score and the ground truth IOU. We apply this loss in both the source and the target domains. However, for the target domain, we cannot obtain the ground truth IOU because of the absence of annotations in the target domain. To this end, we propose an intuitive method to pick the maximum IOU with other predictions as a substituted of ground truth IOU. The insight behind this is that positive boxes often closely surrounded the ground truth box with a large overlap, while the negative boxes generally deviate from each other with only a small overlap. Besides, we also propose a harmonious measure. It considers not only the quality from classification and localization branches, but also the harmony between scores from classification and localization branches. We use the Harmonious measure to weight the self-training noise for all the prediction of the teacher model. Our method chose the single detector focus. The backbone is the VG16 pre-trained ImageNet. Now we will show both quantitative and qualitative results of our model. We evaluate the proposed method on 4 cross-domain detection tasks. We take the adaptation from cityscapes to foggy cityscapes as the example. It clearly shows that our proposed Harmonious Teacher outperforms the existing methods by a large margin. More results on other benchmarks can be referred to our paper. We also conduct an ablation study to evaluate the effect of each component of the proposed method. We can observe that the proposed supervised and unsupervised harmonious learning, harmonious reweighting could improve the detection ability on the target domain. Besides, we also provide quantitative results for visual inspection. We can say that our Harmonious Teacher could accurately detect more objects in the images. If you have any questions about this paper, welcome to contact me via email. Thanks for watching this video.